on our team. And so the short answer is no, you cannot reverse or rewind an iterator to the beginning. The purpose of an iterator is to move through a list forwards. So if you want to do something like reset the iterator or move backwards, what you can actually do is to create an index of the data and then use that index to move backwards through the data. But this is quite inefficient because if you think about it, what you have to do if you use an index is that you have to load your entire data set into memory, then create an index, and then move through the index one by one. So from a data science perspective, if your data is maybe 100 gigabytes, and that's much larger than what your laptop can handle. So you can imagine how slow it would be if you had to load everything into your computer's memory, create an index, and then reverse through it. One option you could think about is to use the sort function on your list or your data structure to change the order of the data points and then use an iterator to move forward through the list. Yeah, that's the gist of it.
Wow, okay, that's good. So now we'll move on to the second questions, right? So for the second question, so it is in a data frame with one string column and one number, default index 64 column. Selecting a row generates a data series of object D type. So does pandas actually convert to a lowest common multiple of column D types?
Ooh, what do you think, Tern?
Actually, maybe if ordered, you can read. This is it, right?
What has your experience been with working with string columns and numbers? Have you actually tried to access a row within the pandas data frame?
Yes, so if working with a column that have mixed data type like with strings and with integers, I think the best way is to clean up the columns because otherwise it's very hard to work with the data, right? So I think it's really depending on what is the data types you're working with. So usually one variable should have a standard data type. It should be either a string or it should be just all values in terms of integers. If things mixed together, I think you could explore either separating them or convert them all into the same data type. What do you think, Jin?
Yeah, okay. So that's usually what you would do with data frame columns, which is a very good answer, Turko. So a lot of times what we'll do is that we're trying to clean up values within the column. So this question is really quite interesting, I thought, because the question here asks about what happens when you have two columns and then you want to access the row within that. So you want to access the row within the data frame. So what's happening here is that you get an object data type, and that object data type refers to the row itself and not to the string column or the number column. So the row itself inside the data frame has its own data type. That's why you're seeing the object data type inside it. So if you were to access the elements inside the row, then element 1 inside the row would be your string column, and then you'd get a string data type. Then element 2 of the row would be your number, and then you'd get a number data type. So that is actually what is going on here. So this is a very interesting question because what we normally work with are columns, like Turnbull explained, but now this question is asking about the rows, and so now we know the row itself is its own data object.
Yeah, and one more point of note as well. Sometimes I think when you import the data, the variables could be stored in a row. So I think it's best if you switch it around such that all the variables is in each column, because I think usually that's how data scientists will work, right? So each column is one variables instead of one row, one variables. Otherwise, it's against the convention. It's very hard to work with.
Yeah, I know, and I've had so many problems with data that is not in the right format. I think actually the way I used to work with data when I was still using Excel was that you always see your data in a long format, in a landscape type format, whereas what Pandas tends to work with is something that is long and thin rather than landscape format like you see in Excel. So the first thing to do actually always is to get your data into a long shape.
Yeah, and just to add as well, I think as a data scientist, I think close to 80% of time is spent on cleaning up the data, like making sure that the data is in the right format, there's no missing rows, there's no missing values. If there is, then you have to figure out how to manage them. And only close to 20% of the time is really spent on training the models, because I think for training models, you can import standard libraries to help you train the models. So I think that relates to your question as well on how much time do we need to spend on data cleaning. Actually, it's a lot of time.
Actually, to me, that's the fun part. I don't know about you.
Okay.
You're the first data scientist that says that it's the fun part.
You say it's the fun. Oh no, what have you been hearing? Because
Everyone says that it's so mundane, just looking through the data, find any missing values, edit it, figure out what to do. And the fun part is analyzing the data, right, rather than cleaning it.
that's a good question. I think, well, firstly, when you clean the data, I think it's the most programmatically challenging. So if you like to think about how you can write a function to clean the data properly, then that is where the skill comes in. Whereas when you're analyzing the data, to me, you're using the same functions again and again.
Yeah, and to clean the data, I think you have to spend a lot of time trying to understand what is the data type and what it is trying to tell you. For example, if the data type is, let's say, male or female, then you see a lot of ones be very, very different.
Yeah, I mean, I also enjoy data cleaning because I think it's only when you really start to clean the data that you get an intuition about the nuances inside the data set. So for example, if you're looking at sales data, then you need to clean the NA values. And then you may find that all the NA values are from this specific market in Indonesia because the network connection is really bad. And so to uncover that kind of story behind the data, to me, it's something that I really enjoy. Data cleaning for the win, guys. It's more fun than you think.
Okay, that's good.
Yeah, so there's actually a second part to question 2. And so the question 2 also asks, is there something like a lowest common multiple of column data types? And I suppose by lowest common multiple, I take it to mean is there like a default or more primitive kind of data type? And so not for pandas, I would say, because for within the pandas package, pandas uses almost only 3 kinds of basic data types, which is your object and your integers and your floats. So something like both an object and an integer are both very primitive data types already. So what pandas is using from the get-go is a common denominator already, and then you can't really compare or rank an object with an integer and a float. So all 3 of them are kind of equal in terms of how basic they are. So I wouldn't say that within pandas there's a hierarchy. Obviously, if you're using maybe other Python packages or other programming languages, then you'd have a hierarchy, but no, not for pandas really. Yeah.
Okay, so now move on to the next questions. So on question 3, let me see. Okay, so it's a question on Ether and Nix. So Jin, what do you think about this question? Have you personally encountered this kind of question before? Or this kind of errors?
Do people ever call iter and next? Yes, so I think this question actually answers itself if you look at the last part. Is this conversion to iterator used for streaming applications? And the answer is yes. So to read out the question, do people ever call iter and next explicitly? The specific use case where this might happen is if you think about, for example, either you have a very big data set or you have what's called an unbounded data set, where you cannot see where the data ends. You don't know where the next data point is going to come in. So then you would need to call iter, and then iter would move from the first value to the second value to the third value. Then suddenly, because your application is streaming, you get a fourth data point, so then iter will immediately act on that. Then you get another data point coming in, then iter will act on that again. So yeah, usually it's particularly good for streaming applications. I don't know if any one of us have had experience with streaming applications.
No.
Okay, so perhaps for the sake of everybody, it's worth thinking about some examples of where streaming applications might come in. Anything in real time. For example, if you're monitoring the number of cars that come to a car park, and you want to dynamically manage how you recommend car park spaces to people, then you have to keep you have to keep monitoring the counter. And so then the counter will keep increasing, and then because the data, you never know when the counter is going to stop. There's no specific boundary there. Then that's a streaming application. So one thing about streaming and non-streaming applications is that the boundary is actually quite blurred. You can imagine that using our car park example, if you're just going to sample the data at the end of every day, and then the next day you analyze the data, then suddenly that's not a streaming application anymore, because you get a data set, and then that data set is 1 day's worth of data. You can put a specific boundary on it. So then it's not a streaming set of data anymore. So usually people get really excited about streaming applications, and I know everybody has heard a lot about smart cities and how it's going to be the next big thing, and IoT, and we're going to have lots of sensors all over the place, and it's a really cool technical challenge. And also actually 9 times out of 10, you could probably convert your streaming application into a batch application and then use standard batch processing techniques on it. Then you don't have to overcomplicate your data and your processing pipeline. So yeah, that is question 3.
Okay, so on question 4, it's a question on global variables. So global variables, so have you personally worked with global variables before? Because for me, when I work with projects, I seldom use global variables, because I mean global variables, when you define it, you have to mentally keep track of it. And if you make some changes to the names, right, it affects the entire program. So I think it's kind of like dangerous to actually change the global variables name. So instead of doing that, you can actually copy the data frame into another variables and work with it instead of changing it. What do you think, Jin?
Yes, I think the short answer to this question is do not try to work with global variables. So the idea of global variables is actually a programming concept rather than a data science concept. And you run into all sorts of problems when you use global variables, because suddenly you don't know which application or which Python script is using what. So when you're working with concurrency, then it can rapidly become very complicated, because any program can access the variable from everywhere. Then yeah, that can create many problems, and a lot of times, because you don't know which program is accessing the variable, it's very hard to debug it.
Yeah, and I think what's dangerous is that if if halfway through you're actually doing some changes to the Google variables, we are not aware of it, and you are still using it as though you think that that's the original data set, then when you go down further down applications, you might encounter a lot of bugs which you don't know what is happening. And it could be just because that you need some changes to the Google variables which you are not aware of.
Yes, exactly, which is really bad. So what should you do instead? Well, then you can only use, you should maybe, the recommendation is to use global variables only for static variables that you don't expect will change. Then you can define it as a global variable, because then you know nobody's going to access that variable and change it. You just want to fix it.
Okay.
Yeah. So then, yeah, that's pretty much it. And don't use global variables.
I think use it strategically. Like for example, if you think that there's some data that you think that is static and don't change, then I think it makes sense to use it as a Google variables. Otherwise, I don't think you should be using that often in the data science project.
Yeah, because what I encounter, and probably you have experience with this as well, Tern, is that when you're working with data itself, you're actually reshaping the data by looking at the averages. Then you might create a pivot table, then you create a graph, then you run the model through it. So even through the course of the normal data science project, you're already defining all this intermediate data sets and these intermediate variables. So then if you were to also define and have to deal with the whole global local problem while also dealing with the intermediate data sets and your functions, and that's just a mess. So with that, let's move on to question 5. Oh, that's the same thing. Okay, question 6. How do you know what exceptions to specify in an except clause? Should you begin without an except clause and experiment with different inputs and states, then decide which of those to handle? Okay, so apparently there are about 2 schools of thought to this. Obviously, you can take the I'm going to catch everything approach and start programming as many exceptions as you can think of. And that falls into the school of defensive programming, because you're taking a very defensive stance and you're trying to preempt everything and just lock everything down. And then there's the non-defensive stance where you just let something pass, basically. Like you start with nothing and then let the error surface to the user. Then that is usually during, for example, the first release of a software package, during the alpha release or the 0.1 release. Then people start filing bug reports. Then it's through that user feedback, then you start to see where your program is failing. Then, yeah.
Is there a specific time or place to use defensive method, like you mentioned?
Yes. Usually sometimes when you can preempt, or you know what you want to do, or you can anticipate the problems that may come up. So one very good example is when you're trying to read in the file and then the user doesn't specify the file correctly, then the typo. I mean, that always happens. I don't know if that always happens. So then you can put in an exception for that. That's a file does not exist error.
Yeah, I think for me, when I first work on the project, I don't spend too much time on an exception because we never know what we are doing will make sense in the end. It could be it's just a piece of rubbish code, you just delete it, right? So if you spend too much time trying to handle the exceptions on the code, but in the end, you realize that what you code is not necessary or doesn't suit the purpose, then you have wasted a lot of time. So I think my recommendation is to actually you can just proceed the coding first. don't need to spend too much time on handling the exceptions. It's only towards the end when you think that it is like production ready, meaning that you are about to share with other people outside of your department or the users who you think might encounter errors, and you think that the program is really suitable to meet their needs, then you will spend time doing the exceptions handling to ensure that the user will have a better experience using it. But otherwise, you shouldn't spend too much time on it, because anyway, if your boss tells you that you have to do this for within 1 week, you spend 3 days doing exceptions, you can't deliver the project. I mean, that's very bad. So get the project delivered first. Then when the boss starts having errors, then
the boss starts having errors. Yeah, that's a very good answer, isn't it? And there's all these real world practical considerations.
Yeah.
Yeah, that's true as well. And definitely, I would say, I think this came up during one of our apprentice discussions, isn't it, Temple, where we talked about what's the minimum amount of code needed to define your baseline model, and what's the minimum amount of code you need to get your program running.
Yeah.
Yeah, and so to that point, what we were talking about was basically the point of doing data science is actually to iterate as fast as possible. So the sooner you can get a working model going, the better, and then you can keep refining it as you go along or try different.
Yeah, so I think you can approach this as a concept of MVP, right? Minimum viable product. So in MVP, you don't spend too much time on the exception side. Just make sure that you get working prototype. Once you get working prototype, then you ask your boss for more budget, then you can work on the exceptions, right?
Yeah, then you can spend more time and refine it.
Can I ask then, what's the answer to the question? Is there a minimum code to a proper prototype?
Yeah, is there a minimum amount of code?
The lesser the better to get working
prototype. The lesser the better, and also from a data science perspective, the less amount of time spent, the better. So one example is if you have missing values inside your data set, or if you have outliers, then it's just really fast to drop your missing values, even though you're losing data. It's just much easier to drop the values first and then run your first model, see what model accuracy you get. Then based on that, you can say that that is your baseline. Then you can go back again, and in your second iteration, you can start looking for patterns in your missing values and move forward.
Yeah. Okay. So the next question. Okay.
When there are multiple accepts for a try, what is a good design strategy for the order of specifying them? Sir?
Yes, so there is recommended to go from general to specific. So Yep. So yeah, the design recommendation. Oh no, I'm sorry. It's recommended to go from the most limiting to the most general exception. So from specific to general. Is there any reason to go down the hierarchy? Probably not. Yeah. Yeah, I think that is all I have.
Yeah.
Because this probably relates on to the next question. We don't actually have a lot of I don't actually have a lot of experience with designing exception handling. I think this falls into the realm of software engineering, at least. And this ties into question 8, really, which is what are some examples of exception handling specifically for data science besides data validation? And the answer actually is no.
Yeah, I think in a normal data science projects, right, because usually what you do is that you import data from an Excel sheet, then you start processing from there, right? So there's very little chance for user to encounter bugs due to some user inputs, unless in your Python you actually ask for user input. Like for example, if you do a program on the BMI calculator, right? You need the user to input their weight and the height. Then back end you have a very simple functions which calculate the relationship between the height and weight. Then give them a BMI, right? Then you can tell them, hey, you're overweight or you're underweight. So I think it's only in such scenario you actually need to spend time doing the exceptions, because I realized that there are multiple questions on the same topics, right? On how do you handle exceptions, right? So I think the personal recommendation is that unless you're doing a program which requires a lot of user input at the terminal, otherwise you don't really need to spend too much time on the exception part.
Yeah, I mean, I don't know about you, Tern, but I was racking my brains a lot about this, and pretty much the only example I can think of is you check that you're not dividing by 0. Maybe. And then that was the only example that I could come up with. And I think usually from a data science perspective, you're working with libraries like pandas and scikit-learn. And so most of your brain power, so to speak, is spent on optimizing your models and then writing code to iterate through the different model parameters, and also thinking about how to better do feature engineering of your data and creating visualization. So all of that, you rely on higher level libraries. And maybe one example is if you were to actually write your own data science library. So for example, if you were to create your own version of pandas or your own version of sklearn, then you might have to think about all of this. Maybe if you're working with SciPy and then you want to be a contributor, then you have to implement Gaussian processes in Python. And then you have to write your own code from scratch for doing that. Then you might have to think about specific examples. But other than that, no, really. Yeah. So that's actually quite interesting, because I think there's part of data science with Python that relies on programming. And then there's this quite blur boundary between Python for data science and Python for software engineering.
Yeah, I guess I think just to summarize the discussion so far, right, on the past few questions, right, I think handling exceptions, you shouldn't spend too much time on it. It should be maybe one of your least priorities, unless you think that it's really such a key priority for you that you have to invest so much time into it. Because the last thing that you want is that you do something that has no value to the project and you have to discard it. Then I will cry over it.
I think we've all been there. I spent 2 weeks on this. You're telling me the project is scrapped. Yeah. Okay. So the next question, in Python Data Science Toolbox, the scatter plot default is some weird number. That's happened to me before. And on the next page, the scatter plot actually displays the tick labels. So how to display tick labels properly? There is the xTickLabels parameter in the pyplot function. And again, as we covered last week, you can look at the official documentation of matplotlib. So you can look at the official documentation of matplotlib, and then the parameters you want would be under xTickLabels or yTickLabels, and then you can pass in as a list the explicit labels that you want, and you can probably pass in the column as a parameter.
Yeah, Jim, do you think it's a good time now maybe to give them to show them how would you search for the documentation of that project?
Yes.
So at least the user can understand what's going on. So hang on. Okay, so since crucial user, how will you search for?
Okay, so sometimes I'm lazy to type, so I will put like matplotlib xtick labels because I can't remember the exact function parameter, but I know that there's something called tick labels. We're just trying to share the screen.
Okay.
Right, so then you can see here there's matplotlib pyplot xtick. So again, this is very in real time. So I thought it was xtick labels. So I typed that in, but apparently it's not. It's xticks. Then I can click on the documentation. Then you can see here it shows the ticks. And then I can pass in my labels, which in this case is 1960 to 1964, or whatever the years you want are. So then with this documentation, then I can then go back to the code.
Yeah, and just one more thing to add as well. I think usually in the documentations, towards the bottom, there's also examples that shows you how do you actually use the whatever options that you described here earlier and how to implement it. Yeah. So for example here asterisks. So what can you do with it, right? Okay. So let me switch back to the presentation slides. Okay. So
yeah. So for question 10, for keywords argument, it's supposed to be a dictionary. However, the input is not a dictionary. What is happening? Okay, so yes, it's very true that when you put values into the keywords argument, then Python will store the values as a dictionary. But you do not have to specify the input as a dictionary. It's something that happens under the hood. So you specify the input as your arbitrary number of keyword arguments, but you can just specify it as it is. Then because you've specified it as a keyword argument, then Python will automatically store it under the hood as a dictionary for you to specify later on. Yeah, so I hope that clears it up.
Okay.
Okay, so question 11 is actually the combination of two questions. Let's deal with the second one first. Sanpo, do you want to take it?
Okay, so the easiest way to understand what's the meaning of this message is simply copy and paste it and Google it. Because frankly speaking, there are many type of errors, and I'm sure there are so many programmers out there. There's someone who has the same experience as you. So usually when you Google it, you will be able to get the error message. So let me show you what do you mean by that. So for example, if you just copy this message, and let's say you just go to and paste it. Let me share the screen. Okay, so for instance, right, if you have these errors, simply just Google it. So most of the time, you see, there will be a Stack Overflow. So this is a pretty good place where people have any questions, they can just put it there. So once you open this up, so usually they will put a title, what's the error, and go down, this is the answer. Right, so usually for any kind of errors, not just for this one, if you have any questions, just copy and paste it and search for it. Chances are there will be someone who has really encountered this kind of error, and they have really explained to you what should you do to avoid or what should you do to correct the mistakes.
Yeah, and I think particularly on Stack Overflow, what I always find really useful is not to look at the first answer that comes up, but actually sometimes if you scroll down, you see that there are threads to each answer. For example, you see this And then there's actually more comments at the bottom. So sometimes you see that people are actually debating a particular approach in the comments. And then they're trading off, oh, I think this solution is better or that solution is better. So that's particularly useful to actually scroll down and look at the discussion that's been going on.
Yeah, so I think as a data scientist, right, a lot of time you might encounter weird random errors which you don't know what is it about. So I think it's a good skill set to develop where you actually try to debug it yourself by going online, search for the mistakes message. Then try to see whether if there's anyone who has encountered the same mistakes as you before. And if there is, try to understand the explanation behind it and the rationale. I mean, if you still don't understand it, there are other resources online, other forums. So I'm sure someone will have encountered your errors before, unless you are the pioneer of some special applications where this is the first time encountering such errors. But I think as a beginner, especially for us as beginners or as an intermediate level data scientists, right? I suppose most of the mistakes they encounter are pretty common, and we should be able to resolve it through a simple Google search.
So what are some resources people should reference to?
I think just take Google search. Usually Stack Overflow is a pretty good resources. If you still have some errors, then potentially you can look at the documentations of the specific libraries that you're using, if you're using libraries. Otherwise, you can look at whether there's any error in your syntax or is there anything like that.
Yeah, so if you are coming from a software engineering background, actually, and if you are very familiar with Python already, but not necessarily the data science toolbox in Python, one option is actually to go straight into the source code. If you are very familiar with Python as a software engineer. And I know personally, I've heard stories of more senior engineers sharing their experiences where they say, oh, I don't even look at the tutorials anymore. I don't even look at the documentation anymore. If I'm asked to look at a new library, I just go straight into the source code and read the source code from there. And I was like, oh my God, I have so much respect for you for doing that. So to go back to the question, the second part, file not found error. Well, most probably it's because the program couldn't find your file. So if your file wasn't in the same directory that your program was in, or if your file path was different, then basically the program cannot find your file. Then for an attribute error, what's happening is that every Python object, when you specify a Python object, you can specify it to have attributes or traits, so to speak. So an attribute may be something like, if I'm a dog, then my attribute is that I bark. So in the same way, an integer is a number, right? It's just a number, and so it doesn't have the attribute called keys. Usually what will happen if you call a number and then you ask it for the key attribute, it doesn't have that attribute. So therefore it throws an attribute error. Keys are usually found in data structures like dictionaries. Then you can access the dictionary's keys as an attribute. So that is the meaning behind the error message. Yeah. And this one we have answered. Then, okay, so question 13 is not particularly relevant to Python Data Science Toolbox 1 and 2, but I thought we could just quickly answer it anyway. So suggested pacing for the course, yes. So DataCamp actually has many users, and even internally, they get their internal staff to take DataCamp courses as well. I know like the entire sales team is on the Python for Data Science track as well. So they find like these people are also full-time working adults. It's a nice benchmark. So they find that typical working adults can probably finish about 2 courses per week. And does anyone have any?
We've sent out the full schedule with the topics that we're focusing on earlier on in the administrative email, so you can take a look at that. It's the full schedule is there.
Yeah, okay. And well, speaking from personal experience, actually it took me about 2 weeks to finish one course. So there is some variability. If you want to blast through it, you can, but you can also take it slow. And that is all the questions we have for our AMA, and we are actually just in time for Tern to actually give a live data analysis coding demo.
Okay, so I suppose a lot of people when you start learning data science, a lot of time you are asking how do you actually put whatever you want, how do you apply things that you learn, right? So I just created a very simple example of how do you actually use whatever you learn to actually analyze a data set, right? So what I did was, I'll just go through step by step, everybody, what I did to analyze a set data. It's called Titanic data set. So if you're familiar, or if you're not, you can just Google Titanic Kaggle data. So Kaggle is an online platform where you can participate in competitions. So under this website, right, people will post data that you can just download for free and just play with it to see how well you understand your data science. So for instance, I download all the data from here. So the data is all here. They tell you what are the data columns, the variables, everything, right? So after downloading it, you import it into the Python notebook.
Oh, this is like a classic data set, right? But what is the story behind the data set? What's the context behind it?
Yeah, so to understand the context, definitely you have to go Wikipedia first, read up on what is Titanic. I assume everybody knows about that, right? So if you don't know, go read up on Titanic. Then after understand the background, then you start to analyze the data step by step.
So what's the point about this data set? What question is it trying to answer?
Yeah, so Titanic data set actually wants you to predict one thing, just one thing. Which are the passengers who will survive, and which are the factors that will lead to a passenger be more likely to survive versus more likely to die in the sinking of Titanic. Yeah. So this is the challenge of data science. So how do you use existing data to predict whether a passenger will die or not? Right? Wow. Is it interesting?
That's super interesting. I mean, like, I'm a big fan of the movie, just saying. I'm a big fan of the movie, so being able to interact with the data in this way is just really good.
Okay, so now I'll just do a simple walkthrough of the how a data scientist will usually analyze the problems. Of course, the actual data set is not as simple. I have removed a lot of our columns, and I have pre-cleaned it so that it's easier for us to follow through. You can come back and revisit this problem next time if you want. So of course, first is to import all the libraries like the pandas, the numpy, and this should be very familiar right now. How do you use matplotlib to actually plot library? And Cvon is also a library for you to plot graphs actually. So just click run, import it. So then you import in the data, right? So this is where I will actually use pandas to actually read in the data, right? And these are all the data variables. For example, you have survivor, pCAR, sex, age, fare, and bug. And this is the definition I was trying to tell you. For example, survivor, 1 means yes, passenger survive. 0 means no, it's perish, right? And things like that, right? So now, after importing the data, usually you want to have a data overview, right? So because you import in the data set as Titanic raw, so we want to see the first 5 rows of the data. Usually, you can just put Titanic underscore raw dot head. So this will actually print out the first 5 values of the Titanic data set. Oh, I got typo here. Okay, let's see. All right, let's run it. Okay, see. So by running this command, instantly you can see, okay, these are the top 5 rows, and apparently all survive, and these are the passenger class. Okay, looks pretty good. And let's say if I understand what's the data type, because sometimes the data type will play important role in analysis, right? I want to understand whether the data is float or an integer. So you type data Titanic underscore raw dot info, right? So
definitely, sometimes you can have dates that are encoded as strings, and then
yeah. So from this you can see, all right. So in total we have 712 rows, and all are in integers. And the good thing is that I don't see there's any missing rows. So that's very good. I mean the data is very clean because someone has really cleaned it, right?
I think that is because this is a learning data set, isn't it? So
yeah.
someone has made our lives much easier.
Correct. So another important things that you need to analyze about data is understand what are the data categories, right? So by typing this command and unique, you can understand what kind of different categories of data, what kind of different values of data there is. So you can see, so this is very interesting. For survive is 2 because it's very simple, right? Either you die or you survive. P class is 1, 2, or 3, meaning whether you're top of socio-economic class, which is 1, or 3, which is at the bottom of the socio-economic class, right? And fare, of course, is 219 because every passenger will have a different ticket price, right? So after typing these 3 simple one-line code, you will have a rough understanding of your data set. So this shows you the power of understanding Python and data science, right? Because by using just 3 lines, you have a very good idea of what kind of data set you're working with. So next step is to explore the data, right? So I already brought in this command. So basically, by typing in .corr, right, you're able to see what is the correlations of all the variables together, right? So one line of code shows you everything. For example, if you see embark versus survive is negative correlation, etc. But what if you want to see this in the chart? Because otherwise it's hard to see, right? So it's just one line of code as well. So sns.heatmap and it will be Titanic raw. You run it, bang. So there you go. So so for this, right, you can see that sometimes, right, having the heat map itself is not that relevant because, right, it really depends on what you want to do, right? If you realize, right, I should be plotting this against correlation, not Titanic raw, because Titanic raw is the raw data. If you realize that your graph have weird outputs, right, then you should double check inputs because I should be plotting this against correlation, right, not the original data. And now you see, now you got a right graph here, right? So just one line of code under a heat map, it shows you the correlations of all the variables that you are looking at. So just one line of code, it shows that, okay, under survive, if you compare it against fare, right, you can see that the correlation is pretty high, shows that probably if you pay a higher fare, you're more likely to survive. And this could be because maybe if you can afford higher fare, you're somewhat important and you stay in a better cabin, so have more priority to the lifeboat versus other passengers, right?
It's really cool because then you can see, you can get an insight into what life was.
Yeah, and to compare this versus Microsoft Excel, definitely you can do this in Excel as well, right? Just copy everything here. You copy and paste, put a conditional formatting, can get it done. But the power of Python and data science is that just one line of code, you're able to get everything out instead of going through the normal Excel sheet, right? So next it will be a statistical analysis, for example. So what if I want to try to understand the basics of the statistics, right? Like the mean, the medians, etc. So it's also one line of code. So Titanic underscore raw dot describe. And just run it. There you go. So from here, you can look at all the data, right? The mean, the standard deviation, the percentile, etc. But one thing you see here, right? Something is kind of interesting. Under the fare, right? You realize that the minimum here is 0, but
does that make sense? So the first question you should always ask is, does the data you're looking at make sense to you? Because how can someone go onto the ship without paying any price, right? It's a free ticket, unless you are Jack, you won the ticket shoe gambling, right? If I remember correctly the movie, so maybe that's Jack, right? It's zero.
Oh yeah.
Yeah, but that's probably one. That's an outlier, right? So yeah. So okay. Yeah. So it's interestingly, you can see that sometimes, right, the data itself is very weird. So you might think that maybe it doesn't really make sense to have a zero ticket price.
Yeah.
So let's say if you want to drop the rows with zero values, right? So let's say I want to do a panda drop.
Yeah.
So now let's say I don't know what should be the command be. So I know that, for example, this should be the way, like I want to do a pandas drop row with condition, a certain condition. So what I'll do is I just copy and paste this. Let's just go to any website, copy and paste this. All right, just go to the first one. All right, so I'm showing you how do I get the operations out. Okay, so let's see what other people are talking about. Okay, so this is interesting. So it says here, I can use this to actually drop out the data, right? So you can just copy and paste this. Let me see, is there a better one? Okay, this. Okay, so it says here data frame dot drop. So drop data frame dot score. Score is probably the column less than 50 dot index in place true. Okay, this looks interesting. So let me try this out. So what I'll do is that I will just copy and paste this code. So definitely you can just use it wholesale, right? Data frame refers to Titanic raw. So Titanic underscore raw, right? So just replace all the values of data frame with it. So we just replace, and done, right? So dot score. So dot score probably refers to a column, but right now I want to look at fair. So probably just do a fair, right? So I want to drop anything that's less than, anything that's zero, right? So put anything less than 0.1 dB, right? So in place, okay, so in place is interesting. I don't know what's in place actually. So this is where I can go to look at the documentations. For example, pandas drop. Just Google for it. Okay, so it is. So let's look at what does in place does. So in place, let's see whether there's anything on this. In place. Yes, you see here in place. Okay, so in true, do operation in place, otherwise return none, right? So this tells you that in place is an optional argument. You don't need it to be in there. But let's say, so in case you don't know, in place meaning that are you trying to drop the data in the origin data set? If you don't want, then of course, then you create a new variable, so I call Titanic drop. So you assign whatever that you're going to drop in the new data variables so that it won't affect your origin database, right? So there's a typo here. Okay, so this will be false. Yeah. So after you drop it, you click run. Titanic raw. Okay, that's another typo. Okay, run. Okay, Titanic. Okay, multiple typos. Okay, so after that, after drop, right, you can copy and paste to look at the code again and run it. Bang. See? So now, so now the thing is updated, right? With the things dropped. So it should be dot drop. Yeah, here you go. So you see now the fair, the minimum is 4, it's no longer 0. So this shows you how do you actually go about doing the data science, data processing and analysis based on what you have learned over the past 2 weeks, right? So you learn about the basic of importing data, the basic of doing the pandas operations, which is the .describe.info. We also learn about how do you plot very simple graph, right? The correlations graph, to understand the relationships between all the graphs. So this shows you how powerful Python is in helping you to analyze the data itself, right? So due to time constraint, I'm going to skip everything and go straight to one more interesting data set. So, okay, just 1 minute, right? So instead of doing scatter plot, right, you can do a pair plot as well. So in pair plot, it's also quite powerful. So in doing pie plot, it can shows you all the variables in the scatter plot areas between all the variables. So just one command line, right? It shows you all the relationships between all the variables. So from there, you can do your analysis, right? So I have to stop here because I'm running out of time and my colleague is asking me to stop. So
yeah, we just wanted to save the last few minutes really for some user questions on the live chat. So thank you everyone who's actually been contributing to the discussion. It's really nice to have this community going. I think that's the whole point about this AMA. So we just have one quick question, which is what is the difference between open file name as file and then file equals pd.readcsv? So the main difference is that open file, with the open function, you're using basic Python. And then with pd.readcsv, you're using the pandas library, which is a higher level library instead of base Python. So it's good to use the pandas library because it's optimized for data science. So you can do a lot of things like change the date times or choose the columns that you want, or even specify specific labels that you're interested in. So a lot of the data munging that you do, like dropping NA values, for example, or changing the data types, what is a good idea is to actually front load a lot of all of that data cleaning into the one function called pd.readcsv. So I recommend pd.csv over basic Python. And with that, we are actually bringing this session to a close right on time.
Yeah, so if you have any further questions, feel free to let us know. I'll be glad to answer your questions, right?
Yes, and do we have an idea of next week?
Next week we'll be covering the next 2 modules.
Yes, the next 2 modules on...
Maybe I can show it over here. We'll probably be covering data camps.
Yes. We'll be looking at importing data in Python and also cleaning data in Python.
Well, I guess I'll just give them a quick overview of that already earlier.
Yes, so that was a preview, which was very nice.
So, yeah, the next 2.
So what we'll be looking at is importing data in Python, and we'll be sending out the Zoom webinar link and Poll Everywhere link. So keep an eye on your inboxes.
Yes, and we'll be answering questions in the newsletter as well. So look out for the email.
Yes.
Yeah.
Okay. Thank you, everybody.
Thank you.
Thank you.